All right, this is lesson 2.3, extend the lesson on biconditionals and their definitions. You write a biconditional if both the conditional and the converse are true. A biconditional joins two parts of each conditional with the phrase if and only if. Often we abbreviate if and only if as IFF. The symbol for a biconditional, P implies Q and Q implies P, is actually just written with a double-ended line segment or arrow. Okay? So each conditional statement below is true. We are going to write the converse and determine if it is true. If the converse is true, then we will take the converse and the conditional and rewrite it as a biconditional. Example A. If 3 points are collinear, then they lie on the same line. Well, that's true. The converse of that, Q implies P, says if 3 points lie on the same line, then they are collinear. If 3 points lie on the same line, then they are collinear. And since that is also true, we would drop the if and the then and rewrite it as a biconditional. The biconditional, 3 points are collinear if and only if they lie on the same line. The biconditional, 3 points are collinear if and only if they lie on the same line. We have another example. Example B says if x equals 5, then x plus 15 equals 20, and that's true. The converse of that, if x plus 15 equals 20, then x equals 5 is also true. So we can write this as a biconditional. The biconditional would be x equals 5 if and only if x plus 15 equals 20. X equals 5 if and only if x plus 15 equals 20. All right, now we're going to take a biconditional and we're going to write it into two statements, the conditional and the converse. So let's look at our first biconditional. A number is divided by 3 if and only if the sum of its digits is divisible by 3. Let's see. Well, we could say that if a number is divisible by 3, then the sum of its digits is divisible by 3. If a number is divisible by 3, then the sum of its digits is divisible by 3. And then I can take this conditional and write it as its converse. If the sum of a number's digits is divisible by 3, then the number is divisible by 3. All right, let's try that again. What about this? A number is prime if and only if it has two distinct factors, one and itself. Well, we could say if a number is prime, then it only has two distinct factors, one and itself. If a number is prime, then it has only two distinct factors, one and itself. Then I will take the converse of this conditional, so it will say, if a number only has two distinct factors, one and itself, then it is prime. All right, that's all I have for you. You have that worksheet that you need to complete all. I believe it's 1 through 16. And then girls are doing odds, and I think boys are doing evens. Good luck.